All right, let's get right into it. Today, we're going on a mission, and that mission is to understand how a simple piece of code gets launched onto the blockchain and becomes, well, a permanent part of the digital universe. So you're going to want to buckle up because we're about to start the countdown.
But first, let's just pause on the big question that's driving this whole thing. How does a bunch of text on a screen become unstoppable? I mean, really think about that. Something that can run forever, exactly the way you designed it, with no one anywhere being able to shut it down. That's what we're here to figure out.
You know, when you think about any great space mission, it really just boils down to two things. You've got the payload, the thing you're sending up, and you've got the destination, where it's all going. For us, that payload is a smart contract, and our destination is the Ethereum blockchain.
So what exactly is this payload of ours? Well, a smart contract is basically just a program that automatically runs when certain things happen. The vending machine analogy? It's a good one. You put in a coin, you get a soda. The rules are baked right in. But honestly, for our mission, it's way cooler to think of it as our own high-tech satellite, programmed with a very specific set of instructions it's going to follow perfectly once it's in orbit.
And where's the satellite headed? To the Ethereum blockchain. Now, try to picture Ethereum as this single massive computer that isn't in one place. It's run by thousands of people all across the globe. Nobody owns it, which makes it the absolute perfect place to send our satellite. Because once it's up there, it's just going to orbit forever, completely on its own. Okay, so we've got our payload, we know our destination, but you can't just run over and hit the big red launch button. Not yet. Every mission commander, and in this world, that's the developer, has to go through a supercritical pre-flight checklist. Got to make sure all systems are a go.
And there are three tools you absolutely need. First up, a digital wallet, something like MetaMask. This is basically your ID, your set of launch keys, and how you're going to pay for the whole mission. Second, you need a mission control center. We call it an IDE, and a popular one is Remix. It's where you'll write and manage all your code. And finally, you need some simulation fuel. This is Test Ether you get from what's called a faucet. Think of it as a website that just gives out free, totally valueless crypto so you can practice. It lets you run as many test launches as you want without spending a single real penny.
And now we get to the really fun part, actually building our satellite. This is the stage where a simple idea gets turned into a real, functional piece of tech that's ready to go live on the blockchain.
This happens in two main steps. First, you write the blueprints. That's the actual code, usually in a language like Solidity, and it spells out every single rule our satellite needs to follow. Then you hit compile, and this step is like assembling the satellite itself. It translates your human-readable blueprints into something called bytecode, which is the machine language that giant global Ethereum computer can actually understand. So, our satellite is built, it's ready, and we've arrived at this huge moment. A real fork in the road for every developer out there. Do you run a full-scale simulation just to be safe? Or do you go straight for the live mission, with all the risks and rewards that come with it?
And this choice, it's everything. On one side, you have the simulation, what we call the test net. It's your flight simulator. It's a perfect copy of the real thing where you can mess up, crash, and burn 100 times over with absolutely zero consequences. Then you've got the other option, the live mission on the mainnet. This is the real deal. Every single action is permanent, it's public, and it costs real money. That's why pretty much everyone starts in the simulator, because once you launch for real, there is no going back.
All right, let's assume our simulations went perfectly. It's time for the main event. All the checks are done, the systems are ready, and we are officially entering the final countdown for deployment. You can just feel the excitement in the air.
But let's be real, you can't get a rocket into orbit without a massive amount of fuel, right? You need all that energy to break free. And on Ethereum, the fuel for any operation, especially launching a contract, is called gas.
Look, this isn't just some random fee. Gas is what you pay to that whole global network of computers we were talking about. You're literally paying them for the work they're doing, the energy it takes to check your transaction, add your contract to the blockchain, and make sure your launch is totally secure and successful. It's the cost of admission for using this incredible decentralized machine.
And this is it, the final sequence. Step 1, you connect your wallet, giving the final authorization. Step 2, you approve the gas fee, fueling up the rocket. And then, that final step, the moment of truth. You click deploy and your code ignites, blasting off towards the digital cosmos. After a few moments of just holding your breath, confirmation comes through from mission control. The launch was a success. Your smart contract is now officially live, in orbit on the Ethereum blockchain. And mission success means something huge here. It means your contract has achieved what we call immutability. It's set in stone, literally forever.
So what does life in orbit actually look like? Well, for one, it means your code now has a permanent public address that anyone can find. It means it's going to execute its mission exactly as you programmed it, no exceptions for as long as Ethereum exists. And it means nobody, not you, not anyone, can change it or delete it. It has become, in the truest sense of the word, unstoppable.
And that brings us right back to the beginning, doesn't it? The launch sequence is complete. Your creation is in a permanent orbit, running its code for all time. The power to do that is incredible. So the only question left is, what did you launch?